everybody. I hope you guys are having a wonderful day. Welcome to week 2. So, in this week, we're going to be focusing on the principles of measurement, and we're going to especially be focusing on one-dimensional measurement. So, we will be working a little bit with 2 and 3-dimensional measurement this week, but we'll go into much more depth over the next 2 weeks in the week 3 module and week 4 module. So, this week is really about understanding the principles of measurement and applying those principles to one-dimensional measurement for the most part. So in your case studies this week, you guys are going to see some examples of how teachers have had activities that help students kind of discover for themselves how the measurement process works and what some of the issues are that can come up when you're measuring things. You'll also see some case studies about units of measurement and how you can use different units to measure the same object, as well as the difference between 1 and 2-dimensional measurements. So those are some of the themes you'll see in your case studies this week. For your projects, you guys will be explaining how to convert either 1-dimensional, 2-dimensional, or 3-dimensional units. Or some of you guys will be looking at reasonable units for weight and reasonable units for capacity and how to identify which units are reasonable. So those are your video project topics. And then on the homework, you're going to see some perimeter problems, which is like a 1-dimensional measurement. You'll also be converting units of various dimensions and identifying reasonable units when you're measuring length. So those are kind of the themes that you'll see showing up in class this week. And to start off our video, I want to talk about the measurement process and what the measurement process looks like, regardless of what attribute you're measuring. So the measurement process basically has 4 steps. The first step is you choose an object that you want to measure. So you could tell your class, today we're going to measure our class lizard. And then after you've chosen the object you want to measure, then you need to choose an attribute of that object. So with the lizard, you could say, do we want to measure how heavy the lizard is? Do we want to measure how long the lizard is? Do we want to measure how hot or cold the lizard is? What is the attribute that we want to measure? And based on the attribute you choose, you then choose an appropriate unit. So if you were measuring the weight of the lizard, you would want to either use like pounds or ounces. Probably ounces would be better unless you have like a really big lizard as your pet. But you would choose a unit that's related to weight. And then if you were going to measure the length of the lizard, you'd probably want to choose inches or centimeters because those are length units. If you wanted to measure the temperature of the lizard, you'd either use Fahrenheit or Celsius, or I guess technically you could use Kelvin too, but usually Fahrenheit or Celsius are the best ways to measure temperature. And then once you've identified what type of unit you're going to be using, you can then find the number of units. So let's go through each one of these steps and talk about some of the nuances that show up in each of these steps. So the first one is attributes. So once you've chosen your object and you know what you want to measure, you then have to decide, well, what part of that object do I want to measure? Do I want to measure the length, the area, the volume, capacity, weight, temperature, time, money? And not all objects will have all of these attributes. Like a lizard doesn't really have a money attribute to it. So you won't always be able to measure all of the attributes, but many objects do have multiple attributes. And also keep in mind that an object doesn't have to be a physical object. It can also be like a thought object, like a circle. A circle you can model with a physical piece of paper, but a circle is a circle even if you're just thinking about it. It doesn't have to be a circular piece of paper in order to be a circle. So also the definition of an object can include real life objects that are physically in front of you, or it can also include mental objects like a circle. So anyway, once you've decided your object, you choose the attributes. And these different attributes are going to be measured in different dimensions because if you're measuring the length of something, that's going to be a one-dimensional measurement because you just measure how many inches it is, or how many miles, or some type of one-dimensional measurement. Versus area is a two-dimensional measurement because you look at how many square units you have. Volume is three-dimensional because you're looking at how many cubic units you have, like cubic inches or cubic centimeters. And then capacity, technically, it has one-dimensional units, even though it's measuring three-dimensional space. Because if you think about like the capacity of a water bottle, you could find the volume of the water bottle, which is like how much three-dimensional space is inside of the water bottle, which would equate to the amount of water that the water bottle could hold. So that would be an example of a three-dimensional unit that you're using to describe the volume of the water bottle. But the capacity of the water bottle would be the number of liters that you could put into the water bottle. And the number of liters is a one-dimensional measurement because you just say like, oh, like I have this many liters, like 1.5 liters in this water bottle. And so capacity is usually measured with one-dimensional measurements, even though it's measuring a three-dimensional space. Weight is also something that's measured one-dimensionally. So you would say like it's this many kilograms or this many pounds or this many ounces. Temperature could be measured with either Fahrenheit or Celsius. Time is measured, in seconds and minutes and hours. And money is measured in whatever currency you're working in. So in the United States, it's dollars and cents, but in other countries, there are other units. So those are some of the different attributes that you can measure. And the next step is to choose appropriate units. So we talked about this a little bit on the last slide, but it's really important to make sure that your students understand why you have to find appropriate units. So you'll see this in some of your case studies, but some of the misconceptions that can happen when students are first exploring the idea of measurement is they'll say things like, I'm 12 pounds tall. Well, what they're trying to say is that they're 12 units tall, and maybe they're using like rulers. And what they really meant was that they're 12 rulers tall, but they've heard pounds used in measurement sentences before. And so they just say, I'm 12 pounds tall. But that doesn't actually make any sense because pounds is a unit that measures weight, and inches or meters or centimeters or whatever are the correct units for measuring length. Or you can also use non-standard units. Like in this case, you could say that their foot is however many beans long. So it doesn't always have to be inches or centimeters. You can have non-standard units like these scissors, or this pair of scissors is 6 blocks long, but it's measuring a one-dimensional distance. And the way that you can tell that it's one-dimensional is because it's essentially like a straight line. And we'll talk more about the other dimensions in just a second. But this would be an example of using non-standard units to measure a one-dimensional distance. Another theme that you guys will notice as you read your case studies is that an ideal unit should be consistent. So I think there's one case study where the students like pace out a certain distance. So I think they measure like the size of their playground in paces or something like that. But since all the students have slightly different pace distances, they end up with different numbers, even though they measured the same thing. And so in that case study, it really draws out the concept that ideally, if you're going to measure something and assign units to it, the unit should be consistent. Like if you measure a table and you say like the table is 56 fingers long, well, is that 56 grown-up fingers, 56 kid fingers, or is it 56 baby fingers? Because the length of a human finger varies quite a bit depending on how old you are. And so an ideal unit should be consistent. And the activities that you'll see in the case studies kind of draw that concept out. So you have these different units. And one of the things you guys will be working on in your videos is you'll be exploring how to convert standard units. So, for example, if you are looking at how to measure the length of something, the English system originally started based on less standard units. So, like for example, an inch was defined as 3 barleycorns, which is usually about the same distance, but depending on how big your barleycorns are, it may vary a little bit. Or like a foot was literally the distance of a human foot. But what type of human foot? Is it a grown-up human foot or a kid human foot? So the English system has become more precise, and I don't actually know what the official definition is of a foot now. Um, but originally, it started based on more informal measurements. And the metric system is a little bit more precise because a meter is defined as, I think it's the distance that light travels in a certain fraction of a light year or something like that. I don't remember what the formal definition is, but it's very precise, where it's like always the same distance. And then the rest of the measurements within the metric system are all based on the meter. So if you put 10 meters together, that makes a decameter. If you put, or sorry, a decameter is written like this. So 10 meters makes a decameter, 100 meters makes a hectometer, and 1,000 meters is a kilometer. And then if you split up a meter into fractions, the fractional measurements are also defined. So a decimeter is a tenth of a meter because it takes 10 decimeters to make a meter. A centimeter is 100th of a meter because it takes 100 centimeters to make a meter. And a millimeter is 1,000th of a meter because it takes 1,000 millimeters to make a meter. So the metric system, I wish everybody used because it's way simpler than the English system. But the United States uses the English system. So I guess we're stuck with that. But the metric system can also be a really good way to introduce the idea of decimals because the way that the units are defined is literally the same way that decimals are defined. Because the tenths place in like our place value system is a tenth of the ones place. And so essentially the meter measurement is like the ones place, and then decimeters are like the tenths, centimeters are like the hundredths, and millimeters are like the thousands. So that's just kind of a side thing. But if you're struggling with how to introduce decimals to your students, using the metric system as a model can be a really good way to do that. So these are the units of length that we use in either the English system or the metric system. And the 2-dimensional and 3-dimensional measurements are based on these units of length. So the difference between a 1-dimensional, 2-dimensional, and 3-dimensional measurement is the way that the units are used. So a 1-dimensional measurement just has 1 inch or 1 mile or 1 foot or whatever the unit is as its base measurement. And then you put a bunch of those together to measure the object. So like if you were measuring the distance from your house to your grandma's house, that's a 1-dimensional measurement because you're just putting 1 mile, then another mile, then another mile, like back to back to back until you get to your grandma's house. Versus area is a 2-dimensional measurement because you have 1 inch along one side and 1 inch along the other side. And so there's 2 perpendicular inches that are defining this unit of a square inch. And so that's defined as a 2-dimensional object because there's 2 measurements that go into defining what that unit is, if that makes sense. So area is measured in like square inches or square feet or square miles or square meters. And you also can have 2-dimensional measurements that don't necessarily say square in them. Like, for example, acres are 2-dimensional measurements, even though they don't say square acres. Because an acre is literally defined as a square that has certain side lengths. So area is a 2-dimensional measurement. And then volume is a 3-dimensional measurement that's measured in cubic inches, cubic feet, and cubic miles, etc. Because there's 3 things that go into the construction of that unit. So like you might have 1 foot, 1 foot, and 1 foot. And so you have like three different 1 foot measurements that are measuring the width, the height, and the depth of that cube. And so that's why volume is called a three-dimensional measurement. So one-dimensional measurements should always be used to measure linear space, so like the distance from one spot to another. Two-dimensional measurements should be used to measure flat space, like how much space is there on the top of your desk, or how much space is there in this field where all the sheep are in, or anything that is going to be kind of like a flat measurement. And then volume is whenever you want to make a three-dimensional measurement where you're looking at the space inside of a three-dimensional object. And the units will reflect that. So that's one of the key ideas that you want to teach your students is the difference between one-dimensional, two-dimensional, and three-dimensional space and the units that we use to measure it. And you'll see that theme showing up in some of your case studies as well. So once you've chosen the correct units, then you go ahead and you measure the object. And depending on what your units are, you will use different tools to measure the object. So if you are measuring the linear distance, you might use a ruler to measure the length of this pencil, or you could use non-standard units to measure the length of these scissors and say that those scissors are 3 paper clips long. But it's still a linear measurement because you're measuring the length of that object. If you're measuring the capacity of something, you might use cups and figure out how many cups it takes to fill up your water bottle. If you're measuring the weight, you might use a scale. If you're measuring the time, you might use a stopwatch as your tool to measure the object. If you're measuring volume, you might use some three-dimensional cubes to see how many cubes fit into a tissue box, because that would be measuring the volume of a tissue box. Or if you wanted to find the area of a shape and find the two-dimensional space of the shape, you might use graph paper and draw the shapes on it and count up how many square units are in that particular shape. So there's lots of different ways to measure the object depending on what attribute of the object you want to measure. So in this week, you're going to focus a lot on one-dimensional measurement, but you will have some topics that are related to two and three-dimensional measurement as well. And then next week and the following week, we'll dive into two and three-dimensional measurement in more detail. So since we're focusing on one-dimensional measurement for this week, I want to talk about a couple misconceptions that will show up when your students are first learning how to measure length. So the first one is that if you're using objects to represent the units, they may line up the objects in a way that have gaps or overlaps. So say, for example, you wanted to measure how many jelly beans long this pencil is. Well, one way that a student might measure it in jelly beans that would be inaccurate is like this, because there's space in between these jelly beans and there's some overlap with this jelly bean. And so that's not a precise measurement, because in order for a linear measurement to be accurate, you need to have all the units back to back with no spaces and no overlaps. Another one that could happen is one like this, where they don't use the same part of the object to measure it. So like they might say, oh, like this pencil is 6 paper clips long, but they used like the skinny side of the paper clip here, the long side here, there's some overlaps here and another overlap there. And again, they use the skinny one. And so that would be an example of inconsistent units and also some overlapping units as well. So, and you could explain this to your students without just telling them outright, oh, like it has to be like this, make sure you always do this. You could let them discover this, because one student might say that this pencil is 6 paper clips long, but another student who maybe did it the correct way would say that this pencil is a little bit more than 4 paper clips long. And it's like, well, if it's the same object, it should be the same length regardless of which person does it. And so you could talk about like, well, which one is it? Is it 4 paper clips or is it 6 paper clips long? And how do we define how long this pencil would be? And if you have a discussion about that, the students will start to realize for themselves, like, oh, in order to have an accurate measurement, I have to have the units kind of like back to back in order to measure that. Another thing is sometimes students will measure like a diagonal distance. And it still is a linear distance because you're measuring the distance, but it would be a corner, it doesn't define the length of the rectangle because the length of the rectangle is like the shortest distance. But you could talk about how it is measuring the diagonal of the rectangle. But those will be different distances because they're different lengths. So that can be a misconception that shows up. And another one, especially when you're using rulers, is that the students don't always remember to line up the end of the object with the 0 mark. And that's really important, especially on rulers where you have like a little bit that like is behind 0. Because sometimes students will also line up the end of the pencil with the end of the ruler, not necessarily with the 0 mark. And that's something that you can, again, bring out through different activities that you do because different students might get different results even though they're measuring the same object. So those are some common misconceptions that can happen when they're measuring length. And this is just a quick summary of the types of questions that you can ask your students to help them identify the different steps of measuring length. So you can ask them like, what length are you measuring? Are you measuring the length across the rectangle? Are you doing the diagonal distance across the rectangle? Are you measuring the width of it? You can ask, are your units the same size? Like if you're measuring how many jelly beans long something is, are all of your jelly beans the same size? Or do you have some really big ones and really small ones so they're an inconsistent size? Are there any overlapping or gaps in your measurement? And did you cover the whole length? Or is there part of the object that you didn't measure with those units? And then lastly, is the end of your object lined up with 0 if you're using a ruler? So those are some of the principles of measuring length. And regardless of what attribute you're measuring, the process of measurement is the same for all of them. Because if you were measuring the weight, you would still go through the same process. You'd say, okay, I'm going to measure the weight of my lizard. That's the attribute. The appropriate unit is going to be ounces. And then I'm going to use a scale to measure my lizard. And you could teach the students how to read a scale and how to interpret the meaning of the scale. So that's the basic idea of the measurement process. And on your homework, you guys are going to see some problems with perimeter because perimeter is a one-dimensional measurement. And the measurement we're focusing on this week is one-dimensional. So the word perimeter literally means around measure. So peri, and like the root word peri means around, and meter means to measure. And so the perimeter is the measure of the one-dimensional distance around the outside of a shape. And so the process for finding the perimeter is that you basically just add up all of the side lengths, but it's much more meaningful for students and they'll understand it much better if you introduce it as the one-dimensional distance around the outside of a shape. So the way you could introduce perimeter to your students is you could say, okay, so I have this maybe like a field, and it's kind of a weird shaped field. But these are all of the different measurements that I made around the outside of my field. And I'm wondering how many feet of fence I need to put around the outside of this field. And by introducing perimeter in that way, the students are going to figure out for themselves that they need to add all of those numbers together to find out how long the fence should be to go around the outside. And then after they've discovered their strategy for solving that problem, then you can introduce the vocabulary of saying, this is the perimeter of the shape. And this will also help the students remember the difference between perimeter and area because they'll have experience with the concept of perimeter before they know its name. Versus if you say, this is the perimeter of the shape, you find the perimeter by adding all of the sides. And then, a couple weeks or months later, depending on what grade you teach, you'll say, this is area. And the way you find the area is you multiply the sides. If you introduce it in that way, the students don't have experience with it. And so a lot of them will mix them up and they'll say, wait, is perimeter the one where I add or is perimeter the one where I multiply? But if you give them an experience of perimeter by having them solve a problem before you ever introduce the name, it will give them more context and they'll be more likely to remember what the perimeter of a shape is. So that's kind of the way that I would introduce perimeter to students, is I would introduce it as a word problem and then give them the vocabulary for what that means. And some of the different applications that you can use in your word problems are things like, if I want to put a string around the outside, how long should my string be? Because a string is a one-dimensional measurement. You could talk about fences enclosing a pasture like I did in that last one. You can do picture frames, like how much wood do I need to frame around the outside of a picture? You could do sidewalks around a neighborhood. And one way you can help the students remember the vocabulary of perimeter is you can talk about the phrase of somebody scouting the perimeter, which means that they walk around around the border of whatever land they're protecting, and they scout out the perimeter to make sure that nobody is encroaching on the borders. And that can kind of be a helpful phrase to help them remember what the perimeter is. And when you're assessing perimeter, there's different levels of assessment that you can do to see how much the students understand the concept. So a surface level question might be giving them a shape and asking them to find the perimeter of it. A deeper level of assessment would be to have them draw a shape that has a specific perimeter, because in that case, it requires a much deeper level of understanding of what perimeter means for them to be able to design a shape that has a perimeter versus just finding the perimeter. So that's one thing that you can bring into your assessments. Another thing that can also show up with perimeter is when you have missing measurements. So if you gave your students this diagram of a garden or something like that, and you asked how much fence do I need to go around the outside of my garden, some students who are focused more on the algorithm will say, oh, well, you just do 24 plus 18 plus 15 plus 9, and then you're done, because you just add up all the numbers. But other students will realize that this is not correct, because if you had 9 feet of fence plus 15 feet of fence plus 18 feet of fence plus 24 feet of fence, your garden would still be open on these two sides. And so then you could say, okay, well, what do? Like, we want to have a fence all the way around our garden so like the rabbits don't get in and eat our flowers, or whatever context you want to add to it. And some of the students might be kind of perplexed by this. But then with some prompting sometimes, you can show them that this distance and this distance together takes you from this mark over to this mark. And that's the same as this distance, which was 24. And so if you have these two partial distances, they should add up to 24. And you can write a number sentence like 15 plus what equals 24. And then the students will realize, oh, like this distance right here has to be 9 feet as well, because 9 feet plus 15 feet will equal this whole distance of 24 feet. And then they can use a similar strategy to find out that this side length is also 9 feet, because 9 feet plus 9 feet equals 18 feet. So that's kind of a added level of difficulty that you can add to perimeter problems to help the students conceptualize perimeter in an even deeper way. So those are some of the concepts related to perimeter and one-dimensional measurement. And another topic that you'll also see a little bit of in your homework, as well as the videos, is the idea of converting units. So when you're converting units, you take one type of measurement and convert it to another type. So for example, if you were measuring this pencil, you might measure it in centimeters. And since the end is lined up with 0 and this other end is lined up with the 15 mark, you could say that it's 15 centimeters. But you could also convert this into millimeters because every single one of these centimeters is 10 millimeters. And so you could also say that this is equal or equivalent to 150 millimeters. And so some of you guys for your video projects will be explaining how to convert units between different types of measurements. And then some of you will also be looking at how to convert two-dimensional units or three-dimensional units. So you'll be looking at how many square inches are in a square foot and things like that. So some of you will be working on that for your projects. And if you have any questions on anything, let me know. But I hope that you guys have a great week, and I'll talk to you guys later.